Hello everyone, welcome to the Java tutorials. Today we are going to talk about collections in Java. What are collections, the different types of collections, some of the methods. Today's lecture covers very fundamentals or basics of collections which everybody should know before starting to use them. Let's go ahead and get started. So, what are collections? Basically, in general, not only just Java, but what are collections? It's an object. A collection itself is an object which acts as a container to store other objects. So, like how in the house we have some jars to wherein we can add some grains or biscuits or anything we can store, multiple objects of the same type we can store. That is what is a collection. The jar is a collection object. We have collections in multiple programming languages. Java is not an exception. Now, why is collection so useful? When we talk about programming, we don't just talk about or we don't just work on one piece of data. It's a whole bunch of data. It's a collection of data that we always work on. For example, a collection of students, a list of students, a list of employees, list of items to be sold. Anything you talk about, it's a collection, which means you work upon multiple objects of the same type. Or sometimes you can have different things like users and items, and sellers and buyers, and inventory. Like each one itself could be a collection, right? That is why collections are so important. Java provides framework so that you can process this data. Now you have to remember, in Java, the collections are in memory, which means the permanent storage is the database. You would load the data into different collection objects depending on what type of object it is. That we're going to study a little later, that how do we decide that this set of collections, where to store it. That's a little later. But basically, get the fundamentals, the concept of collection clear in your mind. Now, Java collections provide a lot of objects, ready-made objects, classes for different data types, different processing. Each one has different implementations, different details, a lot of options that you have available. Basically, you can divide Java collections into two broad categories. One is collections, like one on top of the other, so these are the interfaces. The little light yellow one are the interfaces. The light blue ones are abstract classes. And the purple ones are actual classes which has methods implemented. So depending upon your application need, you can either use these ready-made. The most important ones, like which you're using most of them, is array list, tree set, linked list. These are the most common ones that are used. But if you have specialized need, you could implement any of these interfaces and create your own class. Now, all these collections, the one thing common in them is they are like a stack of data, a collection, like how I was talking about a jar, a cookie jar, in which you can keep multiple cookies stacked on one top of each other and then access cookies how you want it. There is another type, which is collection, but basically a different kind, which is map. Map is a different type, not collection in pure sense. In map, you have two sections. There would be a key and a value. So the key would be pointing to a value. Okay. And again, this map interface is this category has lesser number of classes. So as you can see at the topmost, you will have the map interfaces, 4 abstract classes, sorted map, dictionary, abstract map, and you have implementations, hash table, hash map, tree map, okay, properties. So basically it's key value pair in map. So the previous one, it was collections, like a cookie jar, you stack objects on top of each other. Second one, map, which is key values. Again, both of them, the collections and maps, are only for in-memory. They will be stored in Java memory, JVM. They are not permanent storage. For permanent storage, you have databases. Now, implementations. The collection framework consists of collection interfaces, different like what we saw, the light yellow ones, list, maps, sets. These are all interfaces. They form the basic foundations of the collection framework. General purpose implementations, these are the most widely used. You would find these used in many Java programming languages, like hash set, array list, array deck, tree set, tree map, linked list, link hash it. These are used most commonly in Java application programming. Legacy implementations. Earlier, prior to the latest releases of Java, there were vectors and hash tables. They are what you call legacy implementations of collections, and they were retrofitted to implement the collection interfaces. There are some special purpose classes or special purpose implementations. Again, as the name suggests, they can be used for a specific purpose. For example, enum set, enum list, copy on write array set. Okay, these are basically when you have to use concurrency and all. So these are some special purpose implementations. Some implementations are concurrent. They are all part of java.util.concurrent. So if your application is multi-threaded, you will use some of the implementation classes from java.util.concurrent package. For example, a blocking queue. Okay, so a thread safe queue. These are there. Wrapper implementations. Wrapper, they don't do much, but they basically wrap or create a cover over basic implementations and return you a new collection object. Okay, say for example, if you have a regular set and if you call synchronized set, it will return a thread safe version of the set which you pass to it. So this synchronized set is nothing, just a wrapper, like how you wrap a chocolate in its cover. So this set is wrapped in a synchronized. So now what happens is the set becomes thread safe. Convenience implementations, there are some high performance minimal implementations, like only some methods are available. Okay, say for example, singleton sets. So they are typically made available via static factory methods. So there are some singleton. So you don't have to create your own implementations, basically. It's available. Abstract implementations. Abstract implementations are nothing but just classes with abstract classes, with abstract methods, which you can extend and override the methods. So that you can have your own custom implementations. Many algorithms are provided. Like if you use arrays, there are sort, binary search, binary tree. I mean, many algorithms are already implemented and given it to you. Infrastructure, they're nothing but just the interfaces that we saw, like for example the collection interface, the set interface. They are nothing but the infrastructure items. There is array utility classes, so utility functions for arrays of primitive types and reference objects. Okay, so not strictly it's a part of the collection framework, but this feature was added to the Java platform at the same time as the collection frameworks and relies on some infrastructure and same infrastructure. Sorry. We'll be seeing some of the examples of array class or array utility class in the next lecture. So that is it for the fundamentals. So again, what is a Java collection? Objects which can store other objects in them, in a nutshell. Divided into two broad categories: collections like set, list, queue, different collections, and maps, which is key value pairs, which is missing in this. These are just simple collection of objects. Here there are keys pointing to objects. Different implementations. Most Java classes use these general purpose implementations. But again, if your application has some specific needs, there are many special purpose, convenience, utilities, methods. They are all available. Utilities also have algorithms implemented in them so that you don't have to write your own algorithm, like searching, contains, lot of implementations. So hope the fundamentals are clear for today. In the next lecture, we will dive into seeing all these implementations in actions and how you will use them depending on your need. All right. Thank you for your time and attention. See you all in the next lecture. Bye.